Hello 8th graders, this lesson is all about these things called Bohr diagrams. So up till this point we've learned all about ions and isotopes, protons, neutrons, and electrons, and we've learned about all the parts of the atom. You hopefully know by now that protons and neutrons are found in the nucleus of the atom, but now it is time to turn our attention to the location of electrons. Now this has been something that's been sort of mysterious for a long time, and scientists have revised where they think that the electrons are found over and over again. Well, there was this person named Bohr a long time ago who figured out a model that actually it turns out it wasn't quite totally right, but the way that he made his model helps us to make some predictions about how atoms will behave that still makes his model useful today. So there's a picture at the bottom of your screen. Atoms don't actually look like that, but understanding why he devised this whole model actually helps us to know quite a bit about electrons and atoms. So that's why we learn it still. One of the nice things about Bohr diagrams is that it tells us where everything is in the atom, and it helps us to understand what it's going to do when it bonds to other atoms. So we're going to put protons and neutrons in the middle, and all of our electrons are going to go on these things that are called rings around the outside. You can kind of think of these models sort of like an apartment building. As you're building these things, I want you to imagine that electrons are trying to move into this apartment. And these electrons are super lazy. So if an apartment building was like this picture on your screen and it had no elevator, try to imagine where would the laziest electrons want to live? Probably the first floor. And that's what's true about the atoms too. So the electrons want to live on the lowest rings possible. And then if that ring is full, they move on to the next one and they fill out the rings that way. Now the nice thing about every atom is they all follow the same rules as far as how many can fit on each ring. And that's one of the things that we're going to learn about in practice. So on your paper, there are the steps for making a Bohr diagram, and we're going to do it together with lithium. The very first step is something that we have practiced a whole bunch in this class, and that is to determine the amount of pieces. So we have to figure out the number of protons, neutrons, and electrons. So just as a review, if we're doing lithium straight off the periodic table, our protons are the same as the atomic number. For lithium, that's 3. For electrons, we're going to be dealing with neutral things for the moment, but that will change soon. So it's going to be the same as the protons, 3 again. And then for neutrons, we have to round the atomic mass and then subtract the number of protons. So for lithium, we're going to have 3, 3, and 4 for protons, electrons, and neutrons. Step number 2 is to figure out how many shells or rings we're going to need around our atom. In order to do that, we need the periodic table to do a shortcut, or you can just do some counting. So the electrons will tend to fill the lowest shell first. Remember, they're like those lazy people moving into an apartment building. They don't want to have to climb too many stairs. They like the lowest level. So the ones closest to the nucleus are the most desirable spots. We also need to know how many can fit in each spot. So on your paper, there's a place to put these numbers. In the very first ring, doesn't matter which atom you're talking about, which element, you can only fit 2 electrons. It's kind of a tiny little space. The next ring up can hold 8. The one after that can also hold 8. And then the fourth ring can hold 18. It gets a little bit goofy after that because, like I told you before, it turns out that Bohr wasn't quite right with his atoms drawing. But up until about the 3rd and 4th shell, it's mostly accurate. So 2, 8, 8, 18 are the amount of spaces that each shell can hold. Now we think about lithium. We know that lithium has 3 electrons, so those first 2 spaces on that first ring, they're going to be pretty desirable, so they get filled first. Then the 3rd electron, its only choice left is to fill the 2nd shell. So it's going to go 2 in the first and then 1 in the next. Here's the shortcut though. Check this out. If you look at the periodic table, notice that on the first row of the periodic table, it only has hydrogen and helium. In other words, there are only 2 elements in the first row, kind of like how the first shell can only hold 2 electrons. In the second row of the periodic table, if you count across, there are 8 elements in the second row, just like there are 8 electrons that can go in the second ring. Same for the third row, 8 and 8. And same for the 4th row. So for lithium, we're only going to need 2 shells because it's in the second row. Now we just make our diagram. So I've already got it started for you on your paper. We always put the protons and the neutrons in the center, and sometimes if we're lazy we might just put the symbol, because the Bohr diagram is really mostly about the electrons. Then we have to start filling in the electrons, and we just use dots for these. So we're going to put 2 electrons on the first ring, and then 1 on the second ring, and we are done. On your paper there's a space for you to make the Bohr diagram for neon. Please pause this video and try it yourself. If you're still watching this video, it means you have tried drawing it and you're ready to check your work. So for neon, we're going to have 10 protons, and then we'd round to 20, subtract 10, we're going to have 10 neutrons. And because it's neutral, we're also going to have 10 electrons. In order to place the electrons, you could have counted them out by putting 2 in the first ring and then realizing you have 8 left over and going, can I fit all 8 in the second ring? Yes, you could. Or you can look and see that neon, right here, is in the second row, so it's only going to have 2 rings. So your drawing should look something like this. I kind of took the lazy way, and you can do this too. I put numbers on the rings, especially when the atoms start getting a little bit bigger, just because the dots can get a little bit messy. I encourage you to try the same. On the back side of your paper are some spaces for you to try these practice questions. When you're ready to check your answers, all of the answers can be found in a PDF in Google Classroom for this lesson. Pause this video and try these now. If you're still watching, you have attempted these questions on your screen. Before you continue to the last step, please go and check your answers in Google Classroom. The last step is to go to a PhET game where you're going to click on Build an Atom. So in Google Classroom, there's a link. You'll get 3 choices when you open up the link. Please click the one that says Game. Once you open it up, there are 4 different games for you to play, and as you play through them, it will keep track of your score with these little stars at the bottom. When you are finished trying all 4 games, I want you to take a screen capture, just like I did on my screen, and turn that in for this assignment. Good luck!